Okay, here we are. We're going to start off with atomic radius. In other words, the atoms that are in ground state. The number of electrons equal the number of protons. Clear? So let's do period 3. Period 3 is a horizontal row, starting with what element? What's the first element in period 3, going from left to right?
Sodium.
Sodium, okay? So we're going to say sodium, then magnesium, then aluminum, then what?
Silicon.
Silicon, okay. And then what?
Phosphorus.
Phosphorus, okay.
Sulfur and sulfur.
Sulfur.
Chloride.
And then what?
Chlorine.
Chlorine.
Argon.
Okay. So, now, what is the valence shell of each of these atoms? What's the valence shell of each of the atoms? What's the outer shell? Well, let's write the NLX for each element, okay? Yes, is that okay? 3s1, 3s2, 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. What's the valence shell of each of these atoms? What's the valence shell? What's the valence energy level? What is the outermost energy level? Which one? It's a number. 3. In other words, what's the the valence shell? Okay, or in this case, the principal quantum number. It equals 3, right? Yes? So it's all 3, correct? Yes? So, if I use the Bohr model to determine the electron filling, I would go like this. Let's pretend, okay? Let's go like this. So I would say, if all else is equal, I have something like this. This is the nucleus, let's say, right? Is that okay? That's the nucleus, okay? This is the first shell. That's the first shell, correct? Okay, I'll put the second shell. Would you agree that that's the second shell? Is that okay?
Yes.
I know what you're going to say. You've seen better. Okay, I'm looking for a blue marker. Let me get a blue marker. Okay, now I'm going to build the third shell. Okay, this is the third shell. Okay. Now, what keeps the electrons in orbit? What keeps the electrons in orbit? What holds the electrons in orbit? Starts with an N.
Nucleus.
The nucleus. And what in the nucleus specifically holds the electrons in orbit? Starts with a P.
Protons.
Protons. I feel like a dentist today. Okay? Good. Now, let me ask you this. It's essentially, therefore, the nuclear charge that holds the electrons in orbit. Would that be correct? Yes or no? Yes or no? Is that correct? Can I have a yes? May I have at least one yes?
Yes.
I'll buy a vowel. No, I don't want to buy a vowel. I want to buy a yes. Can I have a one yes? How many yeses do we have in the expression? Can I buy a yes? Yes, raise your hand if it's a yes. Excellent. Now I forget what the question was, but I'll take the yes. Okay. Let's put down the nuclear charge. What's the nuclear charge for sodium?
Plus.
Plus, yeah, that's a start. Plus what?
1.
No, that's the oxidation state of sodium. What's the nuclear charge? In other words, what's the total charge of the sodium nucleus? Plus what?
0.
0? No. Plus 1? No. Listen to my words. Listen to my words. What is the total nuclear charge of the sodium nucleus? I didn't say, you're giving me the answer to this question. What is the oxidation charge? What is the charge of sodium after it bonds so it has 10 electrons and 11 protons? And you would say positive 10 plus a negative 10 would be plus 1. That's not what I'm asking. I am asking you, what is the absolute positive, absolute total charge within the sodium nucleus? Plus 11. Is that what you just said? Are there mice on your table that you're whispering to? Because that's what it sounds like. Are you? You have your little pet rat on your desk that you're whispering to? Is this Harry Potter? It is. Okay, that's our first problem. Okay? All right, so 11 plus 11. Is that okay? Okay. Plus 11. What's the total charge? What's the total charge of the magnesium atom? The total nuclear. What'd you say?
Plus 12.
Plus what?
12.
Plus 12. Excellent. Couldn't catch the accent, but that's okay. My ears also have an accent. It's very difficult sometimes. Okay. Plus 12. What about aluminum? What is it?
Plus 13.
Plus 13. Can you count?
14.
Keep going.
15. 16. 17. Plus 18.
Okay, those are the nuclear charges, right? Now, may I put in the electrons? How many electrons does sodium have in its valence shell? 1. May I represent it with a black dot? Is that okay? Laura, thank you for the encouragement. I like it. Laura's there. Hey, go for it. Okay, I'm from New Jersey. Hey, just go for it. You know what I'm saying? Okay. All right, excellent. All right, there we go. How about magnesium? 2. You guys are good. I'm telling you, can't pull anything over on you guys. How about aluminum?
3.
You were going to say 2, then you said change it to a 3, and you said 2, 3. Okay. What about silicon?
4.
4, 2, 3, 4. Yeah, 4. Excellent. Finally figured that one out. Okay, multiple guess. All right, how about phosphorus? You can count.
5.
5. Yeah, there we go. Let me draw in some serious electrons here. Okay. How about sulfur? 6. Okay. I hear a lot of people saying 6. I have a student from Uzbekistan. Okay, good. Okay. Okay. Now, what about chlorine?
7.
7. Okay. 7. Okay. 7. Okay. Where are you from? I don't know, but it's 7. Okay. Very good. Okay. Now, let me ask you this. Okay. Now, here is my fingers are representing the third orbital. Okay. Yes. It's about the same, right? More or less. Right? Okay. And in this orbital, I'm putting successive number. I talk much, okay? I'm putting an increasing number of electrons, right? Sodium is 1, 2, 3, 4, 5, 6, 7, 8, right? Okay. Now. Remember, what did we establish? What is holding the electrons in the third orbit? The number of protons, the nuclear charge. Correct? Right? Yes or no?
Yes.
Okay. So what's happening is this. So the nuclear charge is pulling, think of this third ring as the limit of the volume of the atom. Okay? So in other words, this is the radius of the atom. That's the radius of the atom. I don't want to put a dot there. You'll think it's a... Okay? That's the radius of the atom, right? Correct? Now, so essentially, what's holding that third ring in place? It's the nucleus, isn't it? Or is it not? Yes or no?
Yes.
Are you sure? Okay, good. So, think of that nucleus, think of that positive charge as a planet. The more nuclear charge you have there, right, the bigger the planet, right? Yeah? The bigger the moon can be for that planet. You could have literally a moon the size of the Earth for Jupiter or Saturn, couldn't you? Right? Yes or no?
Yes.
Yeah, okay, good. So, what has the biggest charge? Which one has the biggest, what has the biggest nucleus in terms of charge? Sodium or argon? Argon. What's the nuclear charge of argon? What's the nuclear charge of sodium? Okay. If all else is even, if all is even, and they all have the same atomic radius and all is even, if it's 1 electron or 10 electrons or 8 electrons, whatever, does it matter in terms of how that ring is attracted to the nucleus? Not really, does it? Okay. So what's going to have, which nucleus is going to have the greater attraction for the third ring? Argon or sodium? Argon or sodium?
Sodium.
Okay. Let me ask you again. Who said sodium?
Muhammad.
Okay, good, Muhammad. So let me ask you a question. Let me ask you a question. Okay. You're on like tug of war, right? Okay. And you have a gigantic person that you're trying to win against, right?
Yes.
But you're only allowed 11 people, okay? So your 11 people are trying to play tug of war with this giant from Jack and the Beanstalk, right? Okay, good. Now, all right. Now, we're going to go another team. The other team has 18 people that can pull against the gigantic monster, right? Which team do you think is going to win? The one with 18 or the one with 11?
18.
Probably. So which team do you think has the better ability to hold that electron in? This one or this one?
This one.
The argon. Now, I understand there's only one here, but there's 8 here. But I'm making an analogy, not an equation. Okay? I forgot to put the electrons in here. In other words, the ring exists. I wish I had like a ring, a giant ring. Anybody have a ring on them? Does anybody have a ring on their finger?
Here.
May I?
It's not big.
That's all right. Thanks. Okay, this is a ring. Okay, that's the ring. Does that come off? Can you see that? You see it? Okay, that's a ring, right? Now, all these rings, these are the same size for all of them. Sodium through argon, same ring. Now, I'm going to put 1 electron on, or I'm going to put 8 electrons on that ring. Yes? Okay. Which one is going to hold that ring closer to the nucleus? Argon or sodium? Which one's going to hold it closer to the nucleus? Sodium or argon? Argon. So which one do you think is going to have a smaller radius? A smaller atomic radius? Sodium or argon? Argon will be smaller because it's going to literally collapse unto itself. Yes? And it's going to be pulled. Every electron you put in there, because remember, it's the same ring. You yeah, we're putting little doodads on each ring, but is the size of the electron, is it massive? Is the size of the electron massive? No, it's negligible almost. So the mass of it doesn't really matter, does it? It's so tiny, it's literally just the charge, correct? So this atom here is going to be, so put these atoms, list the atoms in order of decreasing atomic radius. What would you be? What would be the biggest radius? Sodium or argon? Sodium. So in terms of decreasing atomic radius, that's the list, aren't they? Isn't it? Yes or no?
Yes.
That's the list. Do you get it? Now, the fact that sodium has a nuclear charge of 11 and argon 18 is extremely significant. Okay? Extremely significant. And what we're calling this is atomic radius, or let's say atomic radii. That's what we're essentially calling this, atomic radii, yes? Now, I'm going to quit, and I'll come back. I'm going to make 4 videos today, and then you can work on your ionization energies. This is number 1. We're going to do, actually 3 videos. We're going to do atomic radius, ionic radius, and then we're going to go to the periodic table, and we're going to look at other things about them. Clear? Yes?
Yes.
Okay, good. So let's quit, and then we're going to come back. I want to erase the board and get set up for the next video.